YouTube. Welcome back. Today we continue our series in system design fundamentals. In the previous videos we talked about the single server setup and we talked about the database and how we can use the database in this the single server setup. Today we want to talk about the scaling and also we want to talk about the load balancing and why we need a load balancing, because when it comes to talk about load balancing you should talk about scaling. When you talk about scaling you talk about load balancing because they all come together. So right now our system gets too many users. We are pretty famous that everything goes well, and this server cannot handle all the traffic by its own anymore. So how can we solve this problem? Let me just first I wanna copy this one. Can we go back, please? Yeah, yeah, that's great. And let's just copy it here. So how can we solve this one? Let's just make the DB, take the DB like that here. I want to take the DB here. So one of the way that we can solve this problem is to give the server, or like add to the server more resources like CPU, RAM, etc., which this we call vertical scaling. So vertical scaling refer also to scale up, means the process of adding more power, CPU, RAM, etc., to your servers. And the horizontal scaling refers to scale out and allows to scale by adding more servers, and I will talk about that in a bit. But right now I want to talk about like when the traffic is low, vertical scaling is a great option, and the simplicity of vertical scaling is its main advantage. So the main advantage of vertical scaling, I can add CPU and RAM to the server, and it's one of the most things that we like about vertical scaling. It's really simple. But we have two problems with the vertical scaling. The first one, the vertical scaling has some limits because it's impossible to add unlimited CPU and memory to the single server. It's not like, it doesn't work like that. The second thing, which is more important, which we have something we call a single point of failure. So the vertical scaling does not have a failover and redundancy. So if one server goes down, the website app goes down with it completely because we have no backup. The horizontal scaling, in the other hand, is more desirable for large scale applications due to the limitation of vertical scaling. So the horizontal scaling in this design, users are connected to the web server directly, and users will be enabled to access website if the web server is offline. If you can see this one here. So users will so in another scenario, if many users access the web server in the same time, and reach its limitation, the web server load limit, users generally experience a slower response. So how can we solve this problem? We said that let's use a horizontal scaling, or let's use scale out. So let's just add more servers. So I will add a new server here, and right now let's see that we have here a lot of users, and these users right now, and instead of going to one server, they will also go to the other server, this one. Okay, so let's just, and the other server will send back to them like that. But how can the user know which server to go to? And if this server, for example, if this server went, I don't want to make it like that, I want to make it red. If this server went down, this one, how the user know this server go down, and instead of going to this, we'll go to this. How this happens? How we can solve this problem? So in order to answer this question, let me delete all of that first. we introduce you load balancing. Ta-da! sorry. Okay, so a load balancer evenly distribute incoming traffic. So when we have two servers, for example here, yeah, let's just copy this one and add here. And yeah. Okay, that's great. So we have the load balancer. The user will send a request to the load balancer directly. Okay, let's just call this one load balancer. And the load balancer will distribute all the incoming requests to these two servers. So we will make sure that there's no server has been overloaded with requests, and we make sure that the user is not connected to a server that is not even there. So let's just pull the DB here. Let's just make it the DB here, and I need to make this one here just also like that. And can I make this one here? And yeah, and let's just do the same. Can I? No, thank you. Can I copy a row, because this will be pretty awesome? Control C, and yeah, and yeah, I can. Can we make this a row? Can I copy this also? Yeah, I can. This is getting quite good. And I love Miro. They have a good. Can I make it like that? And I guess this doesn't look good. I'll be honest. It looks like trash. So yeah. Let me just try to make it look better, because it doesn't look good right now. But anyway, we are not here for the looks. We are to learn, not to make pretty good designs. So a load balancer evenly distributes incoming traffic among web servers that are defined in a load balancer, as you can see here. So as soon as you can see in this design, users connected to the public API of the load balancer. Okay, so basically, instead of having the the IP address of these servers anymore, the user only connect with the IP address with the load balancer. Okay, and users connect to the public IP address of the load balancer directly with this setup. As you can see here, web servers are unreachable directly by clients anymore, for better security. So this is also better security, because you can't access the server directly. So and also private APIs are used for communication between these servers. So a private IP is an IP address reachable only between servers in the same network. However, it is unreachable over the internet. So the load balancer communicates with the web servers through a private IP address. So after a load balancer and a second web server are added, okay, we successfully solved the no failover issue and improved the availability of the web tier. Okay, so let's just try to explain how this worked. So if server 1, let's say that this is server 1, if server 1 goes down or goes offline, all the traffic will be routed to server 2. Okay, this prevents the website from going offline. And we will also add a new healthy web server to the server pool to balance the load. If the website traffic grows rapidly, the two servers are not enough to handle the traffic, the load balancer can handle this problem gracefully. So you only need to add more servers to the web server pool, and sorry, and the load balancer automatically starts to send requests to them. So this is why we need the load balancer, and this is why it's really important. And now the web tier looks good. What about the data tier? This one. The current design has one database, so it's it does not support failover and the redundancy database. So and the redundancy, and we should talk about something called database replication, and we talk about that in the next video. So stay tuned and make sure to subscribe to this video, subscribe to the channel, and make the notification. I don't know, make the notification bell thumbs up or something like that. Just do everything to support my channel so I can put more and more work. So yeah, that's it for this video, and I hope my solution was quite good. If you like my content, make sure to subscribe and hit the notification bell so you will never miss a video, and see you in future problems.